My name is Haim, and I will be discussing the transporters and diseases function of the transporter classification database. If we click on the link over here on the left side, we'll be brought to a new web page that essentially has the function of providing relationships between transporters and their diseases. Naturally, this involves mutations in the genes that encode these transporters, and there are a few databases that are involved that make these connections clear for us. In the left column here, we have the transporter classification ID, which will bring us to the family of proteins that are involved in the diseases that we'll be discussing. In this column, we have the OMIM name. OMIM stands for Online Mendelian Inheritance in Man. It is another database that provides phenotypic relationships to mutations in genes, specifically surrounding diseases. So we have a few diseases over here, but we'll use a specific example in a moment to demonstrate what this page does. This column, protein name, provides the protein, the transporter, or the family of proteins that are involved in the diseases that we are talking about. If we move further to the right here, we have the accession number. These links over here, these texts are identifiers for the protein or transporters in the UniPro database that we can learn more about those. If we were interested, we would just click on these links. And finally, over here in the last column, again, is OMIM, Online Mendelian Inheritance in Man. It provides a link to the phenotype or the diseases that come from mutations in the transporters or defects in the transporters. For demonstrative purposes, I will talk about optic atrophy, and I'm just going to search that over here. And we can see that optic atrophy is certainly here, and all the relevant data is here. So let's just go on a really quick tour. If we were to click on this link over here, which is, again, is the transporter classification ID or identifier, we would be brought to the family of proteins that are involved in optic atrophy. And here we can see that it's a three-component system, the mitochondrial inner-outer membrane fusion family, and these are the three proteins that are involved in optic atrophy. If we look in the protein name column, we'll see that the three proteins that were mentioned over here in the family or the complex involved in developing optic atrophy are also just mentioned over here. Here it's in text format. There we had the option of further exploring each of the proteins if we wanted to. If we were to click on the UniPro identifier, we'd be brought to the protein that plays the most critical role in the development of optic atrophy. In this case, it is dynamin-like 120 kilodalton protein, part of the mitochondrial complex, which we saw earlier in the transporter classification page at the link that we clicked over here. And if we were to go into OMIM, we would find discussion about the disease that we're talking about, which is optic atrophy, and the genes that, if mutated, will lead to the disease, and that's the OPA1 gene. And just to confirm, if we go back, we'll see that the OPA1 gene is also mentioned over here. OMIM provides a lot of information. It'll tell you, once again, the genes that are mutated to cause the defects in the transporters that cause optic atrophy. It'll provide description of the disease, clinical features of the disease, and I think one of the things that are really interesting about OMIM is that it actually parses through the text and the research done about the disease and presents it in a very readable and informative way. Over here you can see it's not a link to the page, although that is provided. It's summarized clearly and succinctly so that we can access that information easily and process it without having to parse through a very dense scientific paper. So if we were to go through here, we would just find a lot more information about optic atrophy, but the function of the transporters and disease tool on the transporter classification database is to provide those relationships to you, to put them in a centralized location so that they're easy to find and just to make things overall more convenient. And as you can see, in the case of optic atrophy, they are. I have explored other diseases and the relationships with other transporters and defects in genes that that lead to those diseases. To be completely frank, I've found that a lot of times it's a little difficult to relate the protein, the transporter, the gene, and the disease, but that might be due to my lack of scientific knowledge and the relationships that they play with each other. But overall, the transporter classification database is a great tool, and one that I think we should be appreciative for. So hopefully this has been informative, and thank you for watching.